Okay, so I was talking about a real-time animator for the everything game, so you could come up with animations on whatever people type in, basically. Whatever people's verbal commands are, you could come up with an animation for it. And so with this real-time animator, what about if you created a machine learning program, trained a machine learning program in AI to train it physics, train it on physics, and train it on gestures, and train it on actions, and train it on everything specifically, just how I trained it on eyeballs and noses for 3D modeling. Train it on everything specifically when it comes to animating it. So train it specifically when it comes to arms and joints and hands, and train it specifically, have an AI trained specifically on animating these things in real time, and try to get it in real time. Yeah, and try to get, you don't have to get it in real time, but you try to get it in real time, and go through everything specifically about animation and the animation process, and thing with styles, because if you're going to go through old video games and put in an old video game where you can do everything in the video game now, you want to animate in certain styles too, right? You want to be able to machine learn a style and apply that style to your database, right? So, but but with animation, there's physics, there's timelines, there's nodes. So there's nodes on a timeline that you animate, and those nodes represent like your joint or your arm or your finger or whatever, and that's how we put together timelines on a computer, or animations on a computer, is through a timeline, and that way. So it could machine learn all of our functionalities as well. So the way that we animate it, it could machine learn that, but more specifically, it could be influenced by physical video. You can feed it physical video of people acting and gesturing certain things, and get it to animate, and have an AI or a machine learned way of gesturing, and get it and do it specifically, like have head nods and head bobs, and have a difference between a head nod and a head bob, and have a machine learned, or train a machine learning AI on a head nod, and train a machine learning AI on a head bob, right? That's what I mean, and train it into specific physics. So if the specific physics, such as gravity and stuff, and things that matter to the clothes and to the hair and to what, I don't know how we define physics in our physics engine, but we have a physics engine, right? But our physics engine was written manually and written with math and science. What if we machine learned the physics rather than use math and science? We use math and specific calculations for physics. What if we machine learned the physics instead of exactly by dropping apples from trees? What if we started dropping apples from trees and machine learning the physics, and could we get a faster real time animator out of this faster physics engine, or this more simplified, so, or even more simplified yet sophisticated physics engine, and not just that, but any other engines that apply to animation, such as like the lighting, and because lighting is a big time in real time animation, right? And the materials, lighting and materials, and the modeling that you have to do. So, well, actually, you don't really have to do modeling because it bends the models. It bends the models, but you do have to do the bending and the lighting, and you're doing specific things, right? Depends on how zoomed in you go, right? You have to be able to do all types of things. Like you have to be able to exfoliate skin almost if you zoom in all the way. To have tears coming from eyeballs and stuff, exactly. But but rather than program a real-time animator, use AI to learn animation. Use AI to learn to animate. Use an AI to machine learn all the specifics and details about animation, and put together this collection of AIs that knows how to animate, and you can trigger the AIs to animate for you.